It's a pleasure to have you back on this exciting journey. We are going to learn about the frustum of a cone. But before we do that, what even is a frustum? A frustum simply is what you are left with when you cut off the top of a pyramid. Today, we are going all out on buckets. Yes, buckets. Did you know that if you extend all the sides of a bucket downwards, it eventually becomes a cone? Hope you remember that a cone is a special type of a pyramid, like we learned in previous lessons. This bucket, without the extension, is called the frustum of a cone. We are going to focus on the area which is the curved surface area of this frustum. In finding the curved surface area of a frustum, the whole cone has to be taken into consideration, as the surface area of the frustum will be the surface area of the entire cone minus that of the smaller cone. Let us solve a problem to understand this idea better. Let's find the surface area of a frustum of a cone that has its top and bottom radii as 10 meters and 6 meters respectively, and also has a vertical height of 8 meters. We already know that the formula for finding the surface area of a cone is pi RL. Looking at the parameters we are given, we can see that we are only given the information for the frustum. We have to find the parameters for the bigger cone and smaller cone using the given parameters. If we label the vertical height of the smaller cone as A with a slant height of B and the slant height of the frustum as C, we will have this image. Comparing similar triangles, we have that A over 6 is equal to 8 over 4. We are using 4 in this case because it is the difference between the two radii, and the height of the frustum alone is concerned with this increment. Cross multiplying gives us 4A equal to 6 times 8. Dividing both sides by 4 gives us A equal to 12. Now, using the Pythagoras theorem for the smaller cone, we have 12 squared plus 6 squared is equal to B squared. Solving this will give us the square root of 144 plus 36 equal to B. This will further give us B equal to the square root of 180, which means B is equal to 13.42, which is approximately 13. For the bigger cone, the height is 20 meters. And using the Pythagoras theorem, we have that 20 squared plus 10 squared equals the square root of the hypotenuse of the entire cone, which is B plus C. Let's call B plus C D. This means that 20 squared plus 10 squared is equal to D squared. Solving this gives us the square root of 400 plus 100 equal to D. This means that D is equal to the square root of 500, which gives D as 22.36, which is approximately 22. This means that C is equal to 22 minus 13, which gives us C as 9. The surface area of the frustum, as stated previously, is the surface area of the bigger cone minus that of the smaller cone. This means pi times 10 times 22 minus pi times 6 times 13. Expanding, we have 691.43 minus 245.14, which is equal to 446.29. This means that the surface area of the frustum of the cone in question is equal to 446.29 meters squared. Never forget your units. Your final answer will be considered wrong without it. Now a quick recap. A frustum of a cone is the bucket-like part of the cone, and the surface area of the frustum of the cone is equal to the surface area of the bigger cone minus that of the smaller cone. We will be learning more about frustums in subsequent lessons. Until then, keep practicing and see you in the next lesson.